So let's look at how calculus works with vectors. The position vector is known as S of t. We could put a little arrow on top to note that it's a vector. The component form of that would be x of t, comma, y of t. The velocity vector is the derivative of the position vector. So this is noted as v of t with the vector symbol above, or just v of t. That is s prime of t, and the component form of that vector is x prime of t, comma, y prime of t. The acceleration vector is a of t, the second derivative of the position vector, the first derivative of the velocity vector. We write this as x prime prime of t, comma, y prime prime of t. Speed is the magnitude of the velocity vector. Remember how speed used to be the absolute value of velocity? Same symbol, except when talking about vectors, that single bar doesn't mean absolute value, it means magnitude. The distance traveled is known as the arc length, so we would use the parametric arc length formula. An object is at rest when its velocity is 0. Both components of the velocity vector must equal 0. X prime of t equals 0 and y prime of t equals 0. For example 1, we're given this position vector for the particle moving in the xy plane, and we're going to find the following. So let's begin by graphing. I'm going to set up a txy table. The interval for t is 0 to 2, so I'm going to plug in 0, 1, and 2. For part B, let's find the velocity vector at time t equals 1. V of 1, or the velocity vector at t equals 1, is 6, negative 3. You could put a little arrow above, or you don't have to. The speed of the particle at time t equals 1. Remember that speed is the magnitude of the velocity vector. We're going to take x prime of t and square it, and y prime of t and square it. If t is equal to 1, we already did x prime of t. That is 6. If t equals 1, we also did y prime of t. That is negative 3. So the speed of the particle is approximately 6.708 when you plug it into a calculator. The distance traveled between 0 and 3 would be the arc length from t equals 0 to t equals 3. Go ahead and plug this into a calculator and make sure you're in parametric form. When you do that, you'll get 28.583 rounded or 28.582 truncated. To find the times when the particle is at rest, we're looking for when the velocity vector is equal to 0. We care about the value of t that makes both of them 0, and that would be t equals 0. The object is at rest when time is equal to 0. The acceleration vector component form is 6, 6t minus 6, but I want the form of the vector when t equals 2. Making the component form of the acceleration vector at t equals 2, 6, 6. To find the direction of the particle at time t equals 1 and time t equals 2, first I want to know what is the position at time t equals 1 and the position vector at time t equals 2. I already plugged in t equals 1 and t equals 2 to get the x and y coordinate points to graph the parametric graph. I already know what the position is at 1, and I already know what the position is at t equals 2. Now I need to find the direction of each of these vectors. The direction is the angle between the positive x-axis and the vector itself. Remember, we have a relationship tangent of theta is equal to y over x. Tangent of theta is 0 when theta is equal to 0, or when theta is equal to pi. The vector 12, 0, however, is on the positive x-axis, so we know the theta we're looking for here is 0. Arctan of 2/3. Well, this vector 3, 2 is in the first quadrant, so the calculator is going to give us the correct angle for this. That would be 0.588. Example 2. A particle is moving in the xy plane with acceleration vector here. At time t equals 0, its velocity vector is 0, 3, and its position vector is 2, root 2 over 2. Find the following. They've given us the acceleration vector, and they're asking for the velocity vector. To get the velocity vector when t equals pi/4, we're going to need to integrate the acceleration vector. The integral of -2 cosine t with respect to t is -2 sine t plus c. Now I know the y component will also have a plus c, so I'm going to call this c subscript 1 and the other one c subscript 2. To solve for those c values, when t is equal to 0, the velocity x component is 0, the velocity y component is 3. So first evaluate the velocity vector at t equals 0. We have v of 0 in terms of our first and our second constants, but I know v of 0 is 0, 3. And now I can solve for C1 and C2. C1 is 0, C2 is also 0. That makes our velocity vector -2 sine t, 3 cosine t. In the velocity at t equals pi over 4, plug in pi over 4. The velocity vector at pi/4 is -√2, 3 root 2 over 2. To find the position vector when t equals pi/4, first I'll find the general form of the position vector. This means I'm going to integrate the velocity vector. They gave us the position vector when t equals 0, and that's 2, root 2 over 2. So let's plug in 0 for our position vector. This simplifies to be 2 plus our first constant, the second constant. I was given s of 0, the x part is 2, and the y part is root 2 over 2. Make these equivalent and solve for your constants. Now that we have our c values, we can write our position vector. And now we'll plug in pi/4. And we get root 2, 2 root 2. To find the speed when t equals pi/4, we need the magnitude of the velocity vector at t equals pi/4. We already got the velocity vector at t equals pi/4. X prime of pi/4 is -√2, and y prime of pi/4 is 3 root 2 over 2. which is approximately 2.550 or 2.549. The times when the particle is at rest is when the velocity is equal to 0. Because there is no overlap in our t values, this particle is never at rest. Busy, busy particle. That was funny. It's like a busy bee, but it's a particle. The direction of the particle when t equals pi fourths would be based on the position vector at pi fourths, which was root 2, comma 2 root 2. Set up your equation where tangent of theta is equal to the y component over the x component. And when you use a calculator, you'll get 1.107. Our vector is in the first quadrant, and this angle is in the first quadrant, so that's our correct angle. The distance traveled from 0 to 2 would be the arc length from 0 to 2. So the total distance traveled would be 4.856 or 4.855 truncated. And that is vector calculus.
This is my last cameo. Goodbye.
This is my first cameo. Hello.
I am very glad that everything is over tomorrow. Kind of.
Yes! And with that video, we have completed AP Calculus.